Hello guys, today we are looking at cubic function, the second lesson. And in this lesson, we are going to look at the question from the past exam paper. As you can see it here, question 11. Okay. For 2020 GCE exams, Examinations Council of Zambia. So please make sure that you follow the presentations very well. If you haven't subscribed to this channel, please can you hit the red button down there. Okay, thank you. Let's get started. Okay, so we go back to our question. That's question 11. Okay, this is our question. So let's read the question. Can we read? I hope you've copied the question and you have it. Okay. Okay, so the question says, the variables x and y are connected by the equation y is equals to 3 minus 5x plus x squared plus x cubed. Some of the corresponding values of x and y are given in the table below. So we have the table here, as you can see. The first question is that find the value of r. Find the value of what? R. So, have you seen where r is? I hope you've seen where r is. R is here on the table. So look at this side. We have the x coordinate, the y coordinate, and the x coordinate. So they are asking us, what is the y coordinate when the x coordinate is equal to negative 1? That's what they're asking us to do. What is the y coordinate when the x coordinate is equal to negative 1? So we are using this same equation. We are using this same equation. Where we have x, we are going to put negative 1 so that we find what? We find this y here. Are we together? Okay, so let's do that quickly. Let's do that quickly. So we can say y is equals to 3 minus 5x plus x squared plus 3 plus x cubed. This is the question, isn't it? So what are we saying? Where there is x, we put negative 1 so that we find the value of y, which is r. Okay, so let's do that. So we have what? 3 minus 5 negative 1 plus negative 1 squared plus negative 1 cubed. So let's simplify this. What are we going to get? We're going to get 3 plus 5 because of this minus and this minus. Then here we're going to have plus 1. Okay, then this one will give us minus 1. Are we together? So this gives us a 0 and this one gives us, so r is equals to what? R is equals to 8. Are we together? R is equals to 8. R is equals to 8. So we know now that here where we have r, our true value of r is equals to 8. So I'm going to bring it because this whole question here, as the instruction says, answer the whole question, the whole of this question on a sheet of graph paper. So here is my graph paper. Write your name, your examination number here. Then, so I'm going to say, this is question 11. I'm going to call it question 11. Question 11. Then this was question 11, Roman numeral 1. My R is equals to 8. Are we together? I'm writing my answer here now. So we go now to the second question. Are we together? Taking 2 centimeters to represent 1 unit on the x-axis and 2 centimeters to represent 10 units on the y-axis. For For the y-axis, we'll start from 0 up to 30, knowing that each 2 centimeters represents 10 units. Then for the x-axis, okay, the range is, we should start from negative what? 3 up to positive 3. Okay? So this range and the other one, they're going to help us to know how to demarcate the graph paper. So we should know that for the x-axis, wherever we are going to put our y-axis from, we should know that this side will need 3 units of x, and the other side will also need 3 units of x. Then for the y-axis, for the vertical axis, we don't have the negatives. We do not have the negatives. We'll just start from 0 going up to 30. That is the guide that we have. So let's do that. Let us do that. I can even bring it down here. Okay? Bring it down here. Well, I'm going to say we draw a straight line here. Okay? That is after you've counted that up there you are going to have. So I'm using a pen so that it's clearer. Okay? This is my line. Then this side I'll need 3 and the other side I'll need 3. So the vertical line I can have it here. And since we do not have negatives on the y-axis, I'm going to start right from here. Okay? I'm going to start right from here, going up. Okay? So this is my 0. Let me bring you back to the question. When you look at the question here, what are we told? For the x-axis, it's negative 3 up to 3. They need 2 centimeters to represent 1 unit. All right. So each of these boxes that you are seeing here, these are 2 centimeter boxes. So this, when we are going to have our 1 here, 2 centimeters is representing 1 unit. Then the second one, we're going to have 2. The third one, we are going to have 3. Remember, these are negatives. And we are supposed to go up to negative 3. The other side, it's also up to 3. Are we together? Then as for the y-axis, we've been told it is from what? 0 up to 30. Then we are told what? 2 centimeters to represent 10 units. 2 centimeters represents how many units? 10 units here. Okay? So I'm going to have 2 centimeters, 10 units, 2 centimeters, 10 units, up to 30. So this is how far our axis will be looking like this. We have our x here, then we have our y-axis here. Okay? Then now we have to plot, as we can read the question. What are we told? Draw the graph of y is equals to 3 minus 5x plus x squared plus x cubed. All right. So after we've done this, now we need to plot these points here. These points, we need to plot them on the graph. These points, we need to plot them on the graph. So let's start. I'm sure you have the points. So the first point is what? Negative 3, 0. Negative 3, 0 is the first point. Negative 3, 0. It is this point here. The x coordinate is negative 3. The y coordinate is 0. So it is the same point. The next point is what? Negative 2. That's the x coordinate. And y is there. 9 is the y coordinate. So we have negative 2, 9. Negative 2. So when you count these units here that we have from 0 up to 10, each one of them counts as 1. Okay? So 9 is going to be this one here, right before 10. 9 is going to be this one here. Then the next one is what? Negative 1, comma, r. What is our r? Our r is 8. Negative 1 over 8, which is our r. That is there. Are we together? Then we come to what? 0, 0, 3. 0, 3. 0, 3. 0, 3. I have 1, 2, 3. 0, 3 is here. Are we together? This is where our 0, 3 is. Then we have 1, 0. 1, 0. 1, 0. Where is it? 1, 0. 1, 0. It's this same one here, right on 1. Then we have 2, 5. 2, 5. Then the last one, take note. The last one is what? The last one is 3, 24. So we are dealing with 2, 5. Then the last one will be 3, 24. Take note there. Okay. So 2, 5. 2, 5. So we have 2, 1, 2, 3, 4, 5. Then 3, 20, up to 4. 3 up to 24. 21, 22, 23, 24. Okay. Do you get what I'm explaining here? You get what I'm explaining here? Have you seen? Okay. We have 20 there. So the first one, we have what? This is the 21, 22, 23, 21, 22, 23, 24. In fact, 24 is slightly down here. I've taken it on 25. Okay. Okay. Supposed to be down there. Then now we join. We join these. We are supposed to draw what? A graph. There's this question here. Draw the graph of y is equals to 3 minus 5x plus x squared plus x cubed. So how do we draw the graph? We join these points with a smooth graph. Okay. So this is what we are supposed to do. Are we together? This is what we are supposed to do. We need to join these okay, go up to this one. So this is what we are going to have. This is the graph that we are going to have. If you can do it better than this, there is no harm. Okay, but the idea is this one. Okay, so now we'll proceed. We are going to proceed. We are on Roman numeral 2. Use your graph to calculate an estimate of the gradient of the curve at the point where x is equals to 2. At the point where x is equals to 2. Please pay attention to each of these questions because, like on the gradient, I'll just demonstrate on this question. In the previous lesson, you saw what we dealt with. I'm not covering it here. Okay? So, the gradient. At the point where x is equals to 2. At the point where x is equals to 2 on the graph. So, x is equals to 2 here. X is equals to 2 here. X is equals to 2 at this point. Are we together? So, I'm going to demonstrate two methods that we can use to find the gradient, and then we're going to see which one is more accurate. Okay? So the first one is where we say at this point 2, we draw a tangent. We draw what? A tangent. That is a straight line that just touches this graph at this point. Okay? We draw a tangent here. So let's try to draw that tangent. let's try to draw that tangent, which will be this line here. Okay, so what we are going to do on this line, this same line that I've drawn, we are going to pick two coordinates. We're going to pick 2 points. Okay, 2 points. Now, one of the points is going to be the same one that we were already given. Remember, we were given that this was given as what? 2.5. So we are going to have, we already have this point which is 2,5. Then we need to find another point that lies on this same line, anywhere on this same line. Okay, anywhere on this same line. Any other point, you can find another point. So for me, let me try and find this point here. Let me try and find this point here. And this point, I'm going to call it what? 3, 19. 3,19. If it had a point, if it was going to be 3.19 point whatever, you get it as it is. You have to be as accurate as you can according to the graph. Okay? So, now we need to use the coordinate geometry method to take this as x1, this is y1, our x2, our y2. Then we use the method of gradient, which is represented by the letter m. I write it here. M is equals to what? So that it's clear. Y2 minus y1 over x2 minus x1. Are we together? Then looking at our coordinates here. Okay, we've seen the formula. Looking at our coordinates here, what is our y1? Our y2. Our y2 is 19 over, minus 5, which is our y1, over our x2 is 3 minus our x1, which is 2. So when we subtract this, what do we get? We get 14 over 1, which gives us what? 14. Are we together? 14, we get 14 as our gradient. We get 14 as our gradient. I hope you're following that. Okay. Now, I want to use another method and see what we are going to get. This other method is where we find the derivative of this one, this same equation or function. We find the derivative of this one. Okay? So, let's differentiate this. We have, let me write it here as we have it. What do we have? We have y is equals to 3 minus 5x plus 2x squared minus or plus x cubed. Okay, so I have written it down. Then let's find now the derivative of this one. How do we differentiate this? We want to, it's differentiation now. So the derivative of a constant, it's 0. Then here we're going to remain with minus 5. I'm looking at dy dx. So we have negative 5 here. Then this is going to be what? 2x. This one here is going to be 2x. Are we together? Then this one will be what? 3x, then x squared. So if you haven't understood, you need to look at a presentation on differentiation, or you can check out anything on how to differentiate if this is quite foreign to you. So I'm trying to find the derivative of this one. Okay, where the coefficient of, where the index of x, we are multiplying it by the coefficient, then we less 1. That's what we are doing here. Okay, then at this point, this is the derivative. So in this derivative now, to find the gradient, because this is a gradient, this is a gradient on its own here. Once we have found a derivative of something, it's as good as calling it a gradient. Okay, so at this point now, let's find, we need now to find x coordinate there, was given as in the question. In the question, x, what is the gradient when x is equals to? So meaning we need to use this x to do the substitution here. So we are going to say -5 plus, I'm going to say 2 here, and then we put 2, then 3, then I put what? 2 squared. Okay, I hope it's clear. So we have minus 5 plus 4, then plus, what are we getting here? What are we getting here? This is going to be 4, so we are getting 12. Okay, this side we're getting 12. Okay, so when we add here, we are going to, what are we getting? We're getting -1 plus 12. This is going to give us 11. This is going to give us what? 11. So 11 is the gradient. So you've seen that usually when you use this method, it's not very accurate. It's not very accurate. Sometimes you can easily make those mistakes. And when we use differentiation, this is what we're getting. When we use this one, but in most cases, if there's a difference, but this one gives us the actual gradient. So this is more accurate. Okay, this is more accurate. Then this other one, it's supposed to be closer to what we got. Okay, it's supposed to be closer to what we got here. Supposed to be very close to what we got this side. Okay, so we had, okay, I don't know. Anyway, that is what we're supposed to do. But maybe just to confirm, if we can, you can try out the pairs of other coordinates here to see what you're going to get. But basically, these are the two processes that you can use to get the gradient when you've been asked. Okay, but mostly when they are preparing a marking key, I do believe that they use this one, which is more accurate. So if you can, please go by this one. You are not going to be penalized. Just do your differentiation there and do your substitution, then you find the actual gradient. Okay, basically we're supposed to get something closer, but as you read, if you understood the question here, the question talked about what? Calculate an estimate of. Calculate an estimate of. So that is, if you use this tangent method, most likely you're going to have an estimated answer. All right, so I hope you've gotten what I have demonstrated here. So let's move on to the next question. Let's move on to the next question. Okay, the next question is talking about area. The next question is talking about area. Area bounded by the curve. Area bounded by the curve, and then we are saying where x is equals to what? Where x is equals to negative, where x is equals to -3 and x is equals to -2. Okay, so this is what we are looking at. We are looking at the area bounded by the curve, where x is equals to what? Where x, they have given us that, where x is equals to what? Where x is equals to, where x is equals to -3. So x is equals to -3 here. X is equals to -3 here. Okay? And they have also said where x is equals to what? -2. X is equals to -2 here. So the region that they are talking about, okay? The area or the region that they are talking about, we need to draw this, and then here. So the area, the part that they are talking about, we are going, because even the y domain, or the y parameter also was supposed to be defined. Now, since we are saying in this case, according to what we are seeing here, the y coordinates do not go down here. So we are going to take it that we are confining ourselves to this region here. Okay, this region here, because they have given us the x parameters. This region here is what we are confining ourselves to according to what they said. Okay, according to what they said. So what is the area of this region? Okay, now when it comes to the issues of area, I have to explain something. When it comes to the issues of area, I have to explain something here, and I hope you are going to get my explanation. So area, in most cases, we're going to have maybe a square or a rectangle. There are times when you are going to have a triangle. Okay, a triangle. There are times when you are going to have a trapezium. There are times when you are going to have a trapezium, a shape such as this one. Okay, a shape such as this one. Now you know what a trapezium is. Then it can also, maybe you can have two, okay, trapeziums, or maybe two triangles and the like. So you need to find the area going by the shape that has been given. You can use these shapes to find the area. Sometimes you can find, I don't know if that is advisable, you can find the area of the entire box. When you find the area of the entire box, then you can use estimation. You can use estimation. What am I talking about? What I'm talking about is that if you look at what we've been given here, let me take, for instance, please, this is just for explanation. I'll go up here. This part, we're told that from this point up to this point, it's 10 centimeters. That's what we have been given. The y-axis, 2 centimeters, represent what? 10 units. Then the x-axis, 2 centimeters, represent 1 unit. So if you want to find the area of this one square, this square here, it is going to be, we're going to treat it as a triangle because we have two different measurements. So we have to multiply 10 multiplied by 1. What do we get? This is like a rectangle. So the area of a rectangle is L multiplied by B. So we get 10. Now, when you get this 10, what I was talking about estimation now, if the area that is shaded is just this part here, so it's like now you have to divide. This could be what fraction of 10? You get my point? So maybe you may miscalculate. So it's better if they're asking you to find the area of this one, you treat it as a triangle, then you see how you can find the area of this as a triangle. Okay, so I'm going to look at this part that they are looking for as a triangle. Okay, I'm going to look at this part that they are looking for as a triangle first. Okay, now you know that the area of a triangle is half BH. This is the base and this is the height. So half is 1 over 2 multiplied by the base. The base is from this point up to this point. This is 1 here. This is 1. Take note. This is 1. Multiplied by what? Multiplied by 9. Okay? Multiplied by 9. 9 is the height here. From this point up to this one, it's 9. It doesn't go up to 10. So when you multiply this is as good as 9 divided by 2. And this gives us what? 4.5 centimeter squared. Okay, 4.5 centimeter squared. So this is like half. Okay, because now we are looking at, have you seen what we're supposed to get? Okay, this doesn't go up to 10 there. That is why we cannot get 5, which is half of 10, like I did demonstrate here. No, the height that we are using is 9, it's not 10. So this is what we can get in this case. And the shape that is being formed here is it's an area. I mean, it's a triangle. So we are going to apply the formula of a triangle. So since here we are the triangle, I'm going even to explain in an event where the question was talking about something else. So maybe bringing us back to the question, I'm going to take that. I need to write these answers in a proper order. So maybe there is a second question here where they are asking us to draw the graph. Maybe here we can say refer to the graph. Refer to the graph. What does this mean? Meaning they have to refer to this graph that we have drawn. Okay, then I will come to this part now. This part has got A and B. The A, I said when we use the differentiation method, we got 11. So we have our 11. Then this one, it's 4.5 square. Okay, so this is how we should write down our answers. This is our B and our A. So these are the answers here. Okay, so if you've seen in your question paper, the area part carried 3 marks, gradient 2 marks, the graph 3 marks, the other one R 1 mark, that was 9 marks. Then there's another question that added up to 12 because this is section B where each question carries 12 marks. Okay, so you are going to see how in the subsequent questions this question of tangent and area are going to be covered. So basically this is how the work must come out. You draw the graph, find what they have asked you to do, just like that. Okay, I hope we have learned 1 or 2 things, and I would also appreciate if you go to this first lesson because this is the second lesson of this topic. Okay, so as per our tradition here, because we've taken these lessons as a class, especially during this time of Corona, we always give an exercise so that our people have time to have what to go through after this. So I'm also going to give you things that have to do with the lesson that I presented the previous day. Okay, so let me give you an exercise. Okay, I will have to make another presentation. I think I'll give the comprehensive exercise in the third presentation because this one is the second one. So I need to make another presentation, then give you the exercise. So I hope you've learned something. Okay, make sure you comment on how best we can provide a service. And please, if you haven't subscribed, make sure you subscribe to the channel. Thank you so much for watching.